Okay, greetings to all. In today's session, we are going to start second unit. The second unit contains list operations, general linear list. So what is a list and what are the basic operations we can perform over a list? After that, the special type of list, stack and queue, we will discuss. Okay, in our previous class, we discussed about the prefix expression to postfix expression conversion using recursion. Okay, and in today's session, we will start with the general list, introduction to general list, then basic operations on general list, and then implementation, how to implement it. So these we will discuss. Okay, so what is a general list means? A general linear list is a collection of elements. Okay, so we can access the elements one after another linearly. Okay, and what are the basic operation we can perform over a list means retrieving a particular element, inserting a new element, and modifying the values of a list, and performing delete operation. Okay, deleting an element from the list. So these are some basic operations. The insertion deletion, we can do it in the beginning of the list, or in the middle of the list, or at the end of the list. Okay, in our day-to-day life, we may be in need of maintaining a list of employee details, a list of student details, or list of product details, or list of song details. Like that, we will maintain many lists. In this list, we will add some new values. Suppose if you are taking favorite songs, in favorite songs, we may add a new song, or we may delete some songs from our favorite list, or we may perform sorting operations. Sorting operation based on the song title, or the singer title, or the music director title. Okay, so based on their names, we will perform the sorting operations. Okay, or the release of the album year. Okay, so based on that, we will perform sorting operations. So these are we will to store such kind of details, we are in need of a list. So how to create a list? So normally the basic structure that we know is the arrays concept. Okay, so in array you can store the employee details, or student details, or the song details. Everything we can store it in array. But we already discussed about the disadvantages of arrays concept. So here we are going to implement the list using a linked list concept. So in linked list, each data, suppose one employee means his details, we are going to store in a memory location. The second employee details, it will not be stored subsequent to the one employee. It will be stored in a separate memory location. Then we will use the address to access the second employee details. So the second employee details will be stored in the first employee memory space. The third employee details will be stored in the second employee memory space. So we will sequence. Because of this, it's possible to access the employee details sequentially. So linked list concept we are going to use. Okay, and the basic operations in any list we will perform is insertion, deletion, retrieval, and traversal operations. So apart from this, in this general list, we will study about 10 list operations. To whatever the list we are maintaining, these 10 lists are more the maximum operation that we will perform in any list. Okay, and algorithm for these 10 operations we will discuss. Okay, so this is what we're going to discuss in the next 2 or 3 classes. Today we will start with creating a list and then inserting value into the list. So this we will discuss in today's class. Okay, so if you're taking a list means a list can be an ordered list or unordered list. Okay, so what is ordered list means? Based on some key value or based on some data, the values will be stored in some order. Suppose if you are taking employee details based on employee ID details, so first record is the first employee detail, second record is the second employee ID. Based on their employee ID, the data will be stored. So this is the ordered list. Okay, unordered list means there will not be any order. Okay, so in such cases, where we will insert the record means mostly at the end. So this is called as a chronological list. Okay, adding the record always at the end of the list. Okay, and in ordered list, where how we will perform the insert operation means based on the key value. Suppose if you're taking this example here in the example given here, in the list already we have values 10, 20, 30. Suppose if we wish to insert 25, the 25 must be inserted between 20 and 30 because this is an ordered list. So 10, 20, 25 and 30. So it is in ordered. The same way, if we consider this 10, 20, 30 as an unordered list means we can insert the 25 anywhere. Okay, but mostly we will insert 25 at the end of the list if this is an unordered list. Okay, so these are the 2 types of list. Okay, why we should understand this ordered or unordered list means based on this the type of operation we are performing that may differ. Okay, while inserting, no need to take care of order in unordered list. Okay, we can directly go to the end and insert it. Suppose if it is an ordered list means we need to search the particular location where we need to place the current record, means the new record, and in that particular location we need to insert it. Okay, so this is a insert operation. While performing insert operation, we need to take care of these things. Okay, so delete operation. Normally delete operation, how we can perform means either we can delete the nth record or the record which contains a particular key value, data value, means employee 1 or 2, delete it, or the name Raj. Okay, whatever the record contains the name Raj, delete his details. Like that, we will always perform the delete operation along with search. So we need to perform a search operation. We need to search whether that record exists or not. If the record exists, we will delete it. Otherwise, we will return a message like the record not exists in the list. Okay, so this is about delete operation. Then retrieval operation. Retrieval operation means based on the we will perform the search operation for the given data. Okay, if it is available in the list, then we will return the value of the list. Okay, so it's the data we will return, or its a location we will return. Normally, if you take array means in array we will return the index value, but here we are going to follow the linked list concept. So we will return the address where the data available. Okay, that address will return. That is what we'll do it in the retrieval operation. Okay. The next is traversal operation. Traversal means accessing all the elements of the list one after another linearly. Okay, what is the advantage of, what is the purpose of this traversal means many times we may be in need of updating all the values of the list or updating a particular value of the list. Okay, or searching. So all these process, it requires the traversal. Okay, so traversing means we will iterate the entire list, and each iteration we will navigate to the next element, next element, next element. So this is what traversal operation. Okay. Okay, now these are all the whatever the operations we discussed so far. These are basic operations. Whatever the list you are taking in list, most of the times we'll perform insert operation, delete operation, traversal operation, and retrieval operation. Okay, now how to implement this list? Okay, many data structures we can use like array or other data structures. So here we are going to use the concept of a linked list. Okay, here in the diagram they have given the conceptual view of the linked list and linked implementation view. Okay, so here we are going to maintain two data means two structures. Okay, one is a node structure and another one is a head structure. Okay, node structure means the data. Okay, what are the data we are going to store in each node? Here node means it is a simple structure. In C you might have studied about a structure concept. Okay, so that structure we are going to use to represent a node. Okay, so the node structure, it contains data and also address to the next node. Okay, this is what a node structure contains. In the next slide, we can see it in detail. See here, we are going to create two structures, head structure and data node structure. Okay, head structure contains metadata information. Metadata means data about data. Okay, so if you have a list, how many elements are there in the list? Okay, what is the address of the starting node? What is the address of the ending node? So such kind of information you can store it in the head structure. Okay, and data node structure means what are all the data we are going to store in each node. Okay, and the link to the next node. Okay, so these combinedly will store it in a data node structure. Here data may be a simple primitive type, means integer data or string data or a structure itself. Suppose if you are storing an employee details here, okay, in node structure what we will store means employee ID, employee name, email ID, phone number, everything will store it in the node structure. Okay, here for simplicity purpose, in all our examples we are going to keep only the integer data. So integer data and a pointer link to the next node. Okay, so these are the two node structures we are going to use in the linked list example. Okay, in linked list implementation. Okay, now these are all the 10 operations we are going to discuss in a list. First is creating a list. Next is inserting a node. Next is deleting node, and then a list search, performing a search operation. Then retrieval operation. Then empty list operation, then full list operation, and then list count operation. How many elements are there in the list count operation, then traverse list operation, okay, and finally destroying the list operation. So these are all the 10 most used operation in any list. So if you can able to write program for this 10 list operations, means you can implement any list related data structures or applications, okay. And we are going to see algorithm for all these 10 operations. First, we will start with the create list and insert node. Okay. Now, first, see here, we already discussed that these are all the two structures we are going to use it. Okay. So, creating the head structure, it is what? Create a list. So, initially, when you are creating a structure, what will be the value of count? That is the number of nodes. Is my question?
One, sir.
No,
Zero.
because the count, yes, correct. The count represents the number of data node, not the head structure node. Head structure node is the metadata node. It contains details about the data nodes. So how many data nodes are there? So initially there will not be any data node. So when you are creating a list first time, the count value will be 0 and the head pointer. Once you started creating data node, its address you will store it in the head pointer. Okay. So at the time of creating the head structure, there will not be any data node structures. Okay. So count will be 0 and the head will be pointing to null. Okay. Now that is what create list operation, the first operation. Okay. See here, a create list allocates the head structure and initialize the metadata for the list. So allocating, so in C you might have studied about dynamic memory allocation methods. What are the methods available to allocate memory?
malloc, malloc,
malloc, clog, correct. Malloc, clog. We can use any one of these methods. Okay. So using that method, we need to allocate memory for the head data structure. Okay. After that, we need to initialize the count value and head value. Okay. See here, this is the pseudocode algorithm create list. We are passing the list reference. Okay. And allocate memory for the list, set list head to null, set list count to 0 in create list. So creating a list is over. Okay, creating a list is over. Now, the same, whatever the steps we followed here, what is the equivalent C steps that we will see? Okay, so parallelly you can understand this algorithm and its equivalent code for the, sorry, C code. Okay, once we completed some 4 or 5 operations, I will share the code. Okay, so initially we will see the implementation in C. Okay, then we will see the implementation for CPP. Okay, you can follow whichever you are comfortable. You can use either C code or CPP code, no issues. Okay, now let us see the C equivalent code. Okay, see here, struct list. So this is our head structure. Okay, struct list integer count and struct node star head. Okay, struct node. What is this struct node means? Our data node. Okay, so struct node contains two values, two information. That is integer data and struct node star next. Okay, next means it can here what we will store means the address of the next node, whatever the node we are going to create next, its address we will store it in the star next. We know that pointer variables are used to store the address of a variable. So in this next variable, we will store the address of the next node. Okay. So these are called as a self-referential structures. Its meaning is, see here, structure name is struct node. For the same structure variable, we are creating a pointer variable. Okay. So it contains address of the same type of structure. Okay. Self-referential structures. Okay. So in our we discussed that we need two types of structures to process a linked list. Okay, first structure is a head structure and the second one is a data node structure. So for the two, this is how we need to create a C code structures. Okay, the same here, instead of integer data, if I am asking you to write about employee details. Okay, employee details means how to do it means
creating another structure, sir.
yes, correct. Either we can create another employee structure or here itself we can add the employee details. Both we will see now. Okay, just wait. Okay, so this is one way, including the employee details, employee ID, name, mail ID, salary, whatever the details they're asking in the application or in the program. So that details, including it in the node itself. This is one way. What is the other way means including it in another structure and that structure variable creating it here. Okay, so how to do that means now look at here, we created an employee structure, and for that employee structure we created a variable within the node structure. Okay, so this is how we can use it. Okay, but for in our examples we are going to use simple integer data type. Okay, data for processing. That's it. Now we created two structures. Now how to perform create list operation? See here, create list operation. So in create list operation, for the reference that we are passing to the create list algorithm. Okay, so we need to allocate memory, then assigning the null value to head pointer and assigning the 0 to count. See here, this is our algorithm. L1. L1 is a list reference variable that we are passing create list function. L1 equal to struct list star malloc size of struct list. Okay, malloc function, it will return a void pointer. Okay, that void pointer must be converted to the required data type. Since we are creating a memory for the list node, okay, so here we are giving list pointer, and the parameter is how much memory we need. So we are giving size of struct list. So this is what the purpose of this statement. Now memory allocated. Suppose if there is no memory available or in any there is any error while creating allocating memory. Okay, in such case the malloc function will return null. So if L1 contains null, what is the meaning means error in memory allocation. We are simply returning 0. Okay, otherwise we are initializing L1 count equal to 0 and L1 head equal to null, finally returning 1. So this function, it will allocate memory and returns either 0 or 1. If it returns 0, the meaning is the list is not created. If it returns 1, the meaning is the memory successfully allocated. So this is what the meaning. Okay, so this is the create list algorithm. Okay, see here,
இயர்ஃபோன் எல்லாம் போட்டீங்க?
Arjun, mute Arjun J. Yes. Okay, so this is the algorithm for create list. The equivalent C code is available here. Equivalent create list is the C code is available here. This is how we need to create a list. Okay, now let us call this and check whether the list is created or not. Okay, first we will call and check it. See here, list creation success. Okay, now we created a structure variable, pointer variable for the structure list, struct list star L1, and we are passing it to the create list function, create list of L1. Okay, and this create list will return either 0 or 1. Okay, if it returns 1, it means that memory allocated successfully. So it will go to the else part and prints list creation success. So we got the output as list creation success. Okay, this is what the first algorithm, creating a list. Okay, any doubt in creating list? If you have any doubt, please post it in the chat window. Any doubt? Okay, we'll move to the next algorithm. Okay, now the next algorithm. So the next algorithm is inserting a node. Okay, suppose if we want to insert a new employee record or new student record, new product record. Okay, in such case we need the insert node algorithm. Okay, in insert node, if it is an ordered list or unordered list or whatever it is, mostly there will be three cases. Okay, so before that. Given the predecessor, there are three steps. Means to insert a new node, we need predecessor node. Okay, predecessor means the previous nodes after which node we need to insert the new node. The predecessor node, if we know, then it's possible to insert the new node. Okay, so what are the three steps in inserting a new node? Means first we need to allocate memory for the new node. Okay, how we allocated memory for the head node? The same way we need to create memory for the new node. Then the new node must point to the successor. So whatever the next node, okay, its address must be stored in the new node, and new node's address must be stored in the the predecessor node. Okay, so these changes we need to make. These changes we need to perform. Okay, and while inserting, there are different cases of insert operation. What are the different cases? Means we may insert in an empty list. Okay, or we may insert a new node as a first node in the list. Okay. List contains already some 4 or 5 data. In that 5 data, we are inserting the new node as a first node. So this is another case. And the another case is inserting in the middle. Okay, after the second record or after the third record, inserting the value, inserting in the middle. And the next one is inserting at the end. Okay, inserting at the end. So in this, the first two cases, that is inserting in the beginning and inserting in the empty list. These two are similar, more or less similar. The same way, inserting in the middle and inserting at the end. These two are more or less same operations. We will check the program means the illustration, the pictures. Okay, then we will discuss about the algorithm, and then we go to the implementation. Okay, now let us take the first picture here. Before adding, we have means this is the first we are going to discuss about insert into a empty list. Okay, empty list means list is created. Okay, so list is created means count is 0 and head is pointing to null. Okay, now in this empty list, how to create means insert a new node. So first we need to create a new node. Okay, we created a new node, p new. P new means wherever we are suffixing p in this programming in this text, wherever we are using p prefix, it means a pointer variable. Okay, p new means a pointer variable. Okay, new is a variable name. Okay, so we created a new variable p new, and the data we stored 75. Okay, now head is one node and this is data node. How to link these two means okay, so the new nodes next. Since this is going to be the first node in our list, its next must point to the nothing, null. Okay, and then head must point to the new node. So address of the new node must be stored in head. These two operations we need to perform. Okay, see here. Now let us discuss about the insert at the beginning. Insert at the beginning means we already inserted 75. Now we need to insert 39. So here also the first step is creating the new node. So p new, we created a new node and we stored the value 39. Now the 39, this node must point to 75 and the head must point to this 39. So two pointer changes we need to make. That is p new next. Okay, p new next equal to list head. Whatever the address available in this list head, that address we need to copy into this next of p new. That is 39's successor is 75. Now 39's predecessor, okay, is head. List head pointer. So this 39's address we need to store it in the head. See here in the B, after adding the head is pointing to 39 and 39 is pointing to 75. Okay, so in this picture we are using some arrow marks. What is the arrow mark meaning? Means changing the addresses. Okay, so if an arrow mark is there, it means that that is pointing to that particular address. So that is what the meaning. Here we need to use simple assignment operator. Okay, the pseudo code, if you are looking at, you can understand it. In insert at the beginning, there are two pointer changes. Set p new link equal to list head. Okay, that is the new nodes link. Okay, the new nodes link. Okay, must point to the list head. List head contains address of 75. So that 75's address we are copying to the 39 node. Now, second step is set list head to new node. Okay, list head to means in list head we are storing the address of 39. That is what the second step. Set list head. In list head, store p news address. That's it. So this is what insert at the beginning. Okay, insert at the end, insert at the middle. We will discuss in our later classes. Okay, first we will perform the insert beginning and then display the list. After that, we will go to the next operations. Okay, so this is the second operation we are going to perform, insert beginning. Okay, now what is its equivalent code? See here. So int insert node, we are passing structure list. Okay, and we are creating a new node, struct node, new node. Okay, and allocating memory. Now enter data. We need to enter some data into the node, and the data we are reading. Then new nodes next equal to L1 head. See this picture. Okay, that is new nodes link. Okay, that is new nodes next is a list head. New nodes next is a list head. That is the first step. What is the second step? The list head in the head node, list head in the head node, we need to store the new node address. That is what in the second step we are doing. L1 head equal to new node. Okay, after that the metadata value we need to increment. Okay, so L1 count plus plus. So this insert operation, it is insert into the empty list or insert at the beginning. So that is what this insert operation. Okay, and finally the third operation that what we are going to discuss is the display operation. Okay, so display operation means displaying the content of the traversing the list and displaying the value of the list. So that is printing the list. That is what this algorithm. Okay, the third operation, displaying the list. Okay, so here we need to create a temporary pointer pwalker, and the first address of any list, it is stored in the head data structure. Okay, so pwalker equal to list head, temporary node equal to list head, and what is the last node's next value? It is null. So we need to iterate the loop. Okay, we need to navigate to each node until we find the last node. What is the identification for the last node? The last node's next pointer, it is null. So until pwalker not equal to null, print the pwalker data and set pwalker to pwalker next. So every time the temporary variable must move to the next node. Okay, so node equal to node next. That is what the meaning of this pwalker to pwalker link. Okay, so now its equivalent to C code is, see here, we are passing the list one and struct node walker equal to L1 head. Okay, while walker not equal to null, printf walker data and walker equal to walker next. Okay, this is a displaying the list. Okay, creating a list we discussed, then insert node we discussed, and then displaying we discussed. Okay, so the execution we will see it in the next class. Okay, so in today's class what we discussed means we discussed about what is introduction to general list. So what is a list, how to create a list, and then what are the basic operations of any list, then the linked list implementation. Okay, in implementation what are the operations we are going to discuss. So about that we discussed. Okay, and we discussed three algorithms. There is a creating a list algorithm, and then insert at the beginning algorithm, then display algorithm. These three algorithms we discussed in today's session. Okay, so in next session we will see the rest of the algorithms, operations, and its equivalent algorithms we will see, and the execution for these programs also we will see it in tomorrow next session, and after that I'll share this code. Okay, and today 5 o'clock I have scheduled a demo test. Okay, sample test. All of you attend the sample test. More or less the questions means it is GK questions only we ask. It's since it's a demo. Okay, so some GK question and one algorithm I ask. So please attend the totally there will be 5 questions. Okay, please attend the MCQ, and one question is upload. So you have to write one algorithm, scan it, means take a snapshot of the algorithm. Okay, write it in your notebook, take a photo and upload it. So totally there will be 5 questions and 15 minutes time. Okay, this is a demo test just for practice purpose. While attending this test, if you have experienced any issues, please let me know in the next class. So next class means Thursday class, you inform me. Okay, and Friday and Saturday is your first set of assessments. Okay, Friday one assessment and Saturday another assessment. Okay, please prepare well and attend the assessments well. Now 5 o'clock I scheduled a demo assessment. All of you please attend the demo assessment. Okay, if you have any doubt you can ask now.
Sir, those tests on Friday and Saturday are those MCQs are written descriptive, sir.
One test will be MCQ, one test will be descriptive.
It will be until linked list.
Okay, sir.
Not until linked list, only the first unit.
Okay.
Okay. Any doubt?
Sir, what will be the timings of the test, sir, like on Friday and Saturday?
Timings of the test I'll announce on Thursday. Okay.
Okay, okay, sir.
Either 10 MCQs will be there or 20 MCQs will be there. So the test, the marks is 20 marks. Okay, timings will be, if it is MCQ means timings will be a little bit lesser. For descriptive, you will get a little bit of time more. Okay.
Okay, okay, sir. Thank you, sir.
Okay. Any other doubt? Okay, no doubt. We can leave the session. Thank you.
Thank you, sir.
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 Hello, sir. Sir?
Yes, yes, yes.
I have a small doubt in the hashing method, mid-square method, sir.
Hashing method.
Mid-square method, sir. For example, if we take a 5-digit number,
Yes.
so five-digit number is the key. So what we need to do is we need to square it and take the middle digit as the address, no, sir.
Yes.
If we after squaring, how do we find the middle digit, sir? Suppose if we square a 5-digit number, suppose if we get the answer as some 7 or 8-digit number, then how will we detect the address?
How we will?
How will we know the address? Like middle means how many digits we must take as address?
2 digits. Middle of 2 digits.
Only 2 digits, sir.
Only 2 digits. In mid square, that is what we discussed.
And then if the number is large, you told that we need to take a part and square it, no, sir.
Yes.
Then how to take that part, sir? Is it random or how?
It is random based on the developer. Okay, either the first 3 digits or first, third, and fifth digits. Okay, selection process. So based on the developer and applications requirement, you can select the digits randomly. Because if you are taking 5 digits and square it means, okay, so the resulted number will be more. Okay, integer is not sufficient to store that result. So either we have to go for the long data type, and even if it is a long, sometimes a long also not sufficient. That's why we are going for the selection process. A part of the digits will be selected.
Okay, sir.
Okay, thank you.